Hello and welcome to Foundational Patterns, and I am Mr. X. In this video, we will discuss the syllabus of mathematical literacy for AET Level 4, which is done in community education and training colleges, or simply what is called the CET colleges. Now let's get down to business. In mathematical literacy, we have 4 topics, or what is formally referred to as unit standard titles. So when you see US, it means unit standard. So mathematical literacy is a unit standard based curriculum. So in this case, we have the unit standard ID, which is registered with SACA, which is the South African Qualifications Authority, and these are the unit standard ID numbers. And so our topics are found in the unit standard title. The first one that we see here is describe and represent objects in terms of shape, space, and measurement. So we normally shorten this as a topic to become shape, space, and measurement. And now when you look into the right hand side, we have credits. Credit simply means how much of the work must be done for each topic. So in this case, the shape, space, and measurement topic has 5 credits. That translates to 31 marks in your final exams. Next is the evaluate and solve data handling and probability problems within given contexts. This one we call it data handling and probability, and so it has 5 credits, which translates to 31 marks as well. So in this case, you can see that these two topics carry quite a lot of weight between them. They have over 60% of the mathematical literacy. Now the next one is called work with numbers, operations with numbers, and relationships between numbers. We normally call it working with numbers in short. So this one has 4 credits, and this translates to 25 marks in terms of the weight in the final exam. And finally, we have work with measurement in a variety of contexts. So we normally call this just measurement, and it carries 2 credits, which translates to a total of 13 marks. So mathematical literacy carries 16 credits, which means for you to be able to pass in this level 4, you have to have a total of 120 credits in all the subjects that you're doing. So maths contributes about 16 credits, and so 16 credits translates to 100% of the marks. So when you're writing your exams, you will be writing out of 100 marks. Now, looking into the annual teaching plan quickly, we have the annual teaching plan for AET Level 4, mathematical literacy, which is sometimes has a code called MLMS 4. Now this year, what you're going to do at the beginning of the year, obviously you'll be admitted into your community learning center, and then a placement assessment will be administered to you. So this is a placement assessment test that will enable your teachers to be able to put you in a proper class, either in AET level 1, 2, 3, or 4. So the AET level 4 that we are busy talking about is an exit certificate. Yeah, English. Now, then from there, your first lesson would probably have to do with properties of numbers. So with properties of numbers, we are dealing with describing the real number systems. Okay, so we are talking about your natural numbers, your whole numbers, rational numbers, even numbers, odd numbers, etc. And then we will then progress to integers. In integers, we have properties and calculations. So with integers, we can do calculations involving all four main number operations, which is addition, subtraction, multiplication, as well as division. We also do what is called BODMAS, which is how the order of which calculations must be done. So we have brackets first, and then this is off, or sometimes it's called indices, which means things like your square root bracket comes in there. And then we have division and multiplication going together, addition and subtraction. So sometimes you will see there is something called PEMDAS. All right, so that is just a different iteration of the same thing, or different words that are used. Okay, and then we also have commutative, associative, and distributive law. So for an example, if you have 2 into 7 plus 3, so sometimes you might want to distribute this and that. So you would say this would be 2 times 7 plus 2 times 3. Okay, so this would be 14 plus 6. So this will give you 20. Or alternatively or naturally, you would say 2 into, when you're dealing with BODMAS, 2 into 7 plus 3, that will give you 10. And 2 times 10 gives you 20. So you can see that you are arriving at the same place. So those are some of the things that you will have to do. And then next you deal with additive and multiplicative inverse. So additive inverse simply means that if you have a number such as 1, so the additive inverse of it will be a minus 1. All right. And if you have minus 3, so the additive inverse would be plus 3. Okay, so the inverse simply means the reverse. And then if it is multiplicative inverse, you can have 1 over 4, and the multiplicative inverse would be 4 over 1. So if you multiply this, you'd simply get 1. So something like that. Then next, you will be dealing with factors and multiples. With factors and multiples, this will comprise of the lowest common multiples, and then you will also deal with the highest common factor. And the lowest common multiple usually will lead us to the common thing that we know is the lowest common denominator when we're dealing with fractions. We will also have to deal with the use of prime factorization to find the lowest common multiple and the highest common multiple. And we might also have to do some context-based calculations. What follows after that can be fractions. Okay, with fractions, we will deal with different types of fractions, such as your common fraction of 1 over 2, for instance, or it can be 0.5, which is a decimal fraction. All right, and you can also have things like the mixed fraction, where you have your 3 over 4. So this is a whole number and a fractional part, and which can also be an improper fraction where we'll have 15 over 4, where we have a bigger numerator versus a smaller denominator. And then we can compare fractions and get your equivalent fractions, and we can order and compare fractions. So different ways in which fractions are written can also be compared to see whether these fractions are equal or one fraction is bigger than the other. We can also convert from a different type of fraction. So from mixed fraction, we can have a decimal fraction, or we can convert to an improper fraction, or any other way we can go this way as well. Then next, we will deal with fractions again, but in this case, we are now calculating between fractions, all right? And then we can also deal with a long division method of dividing two numbers, and we can also introduce percentages here as well. So because the percentage is actually a special type of a fraction. And then the next part about fraction, we deal with the ratio, proportions, and rate. So in ratios, we can compare two quantities, such as when, for instance, you have 21 days compared to 4 weeks. So we can see that 21 days is actually going to be 3 weeks of 7 days, 3 weeks of 7 days each. So actually, when you're comparing this, you're saying this will be 3:4. And proportion is actually a little bit higher than the ratios in terms of the demand for it. And then the rate is when we want something such as speed, where you are saying what was the rate in which he was traveling, for instance, 120 kilometers per hour. Or we can also look into the rate for buying meat, for instance. You can say per kg is meat is 79 rands 99 per kg. So things like that. Next, we're looking at exponents. In exponents, we compare and represent numbers in exponential form. So an exponential form would be if we would have a situation where we have 3 to the power 2. So we know that this actually represents 3 times 3. So 3 is repeated twice in multiplication, and this is a base of an exponent, and this is when we raise it to a power. All right, so we would normally say this is 3 to the power 2. Okay, and so if we are comparing and representing numbers in exponential form, so this is an exponential form. This one here is an exponential form, and this is an expanded form. Okay, so this is expanded, and we can also represent it as a numerical value. So 3 times 3 gives us 9. So this is numerical. All right, so these are the 3 different ways in which you can represent a number. And then we can also talk about the laws of the exponents. Laws of the exponents to say, for instance, if we have 3 to the power 2 times 3 to the power 3, the laws of the exponent says that you take the base of these similar exponents, and then you say 2 plus 3. So this will give us 3 to the power 5. So that's a law, but if you would notice, 3 to the power 5 will give us the same answer as 3 to the power 2 times 3 to the power 3. Our syllabus says that we can calculate exponents that include squares and cubes. All right, so we don't do anything higher than maybe 3 to the power 4 or 5 to the power 5, those kind of things. We can go up to a square and a cube, and we also deal with the square roots and the cube roots. So a square root is something like this, and a cube root is something like this. So we can have a cube root of 125, so this will give us 5. Now a lot of students have they do mistakes here, whereby it's when they're supposed to say a cube root, so they write it as 3 times the square root of 125, and ostensibly they will get a wrong answer. And then after that, we can also look into what is called the scientific notation, which essentially comes from the exponents, where a number like 14,000 can be represented as 1,4 times 10 to the power 4. What this means is that a very large number, as you can see in some of your calculators, that when you multiply big numbers, then the number changes, and then you get something like 1,4 times 10 to the power something, and then you don't understand what is happening. That is basically your calculator telling you that you have to, that the number is too big to be represented on this small screen of a calculator, so it then changes the number to a scientific notation. And we can also change a very small number like 0,0375, we can change it into scientific notation, and vice versa. So in this case, it would become 3,75 times 10 to the power negative 2. So if it is a negative exponent, then it means it is a very small number. If it is a positive exponent, then it means it's a large number. From there, again, from exponents, we can go to what is called the binary number system. So this comes from exponents, the binary number systems, and other number systems as well. But the most common one, and that we can do, is we can convert between the decimal number system. So the decimal number system is the numbers from 0 to 9, and these can give us any other number that we want. So as long as we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can build any other number. But in the binary number system, we only have two numbers, so which is 0. Let me use a different color for this one. We can have 0 and we can have 1. All right. So this number system is basically the number system that is understood well by computers, which means 0 means off and 1 means on, just like a switch. Okay, just like a switch. So it means a computer understands that when it sends information, there are parts that it must switch off and there are parts that it must switch on. Computers, cell phones, and those electronic things. So we use binary. We can convert between the ordinary numbers, or we can convert from ordinary numbers to binary numbers, and we can also convert back from binary numbers to ordinary numbers that we know of. There are other number systems, such as the Mayan system, which is base 20, the Babylonian system, which is base 60, and then we also have what we call the Roman numerals, where we are counting as 1, and then this becomes 2, and then we have 3, okay, and then we'll have 4, 5 and 6. Okay, this usually confuses me between 6 and 4. And then tallies would have sticks that are put this way. That will be 1, and then 2, and then 3, 4. Okay, you can see where I'm going. But then it has a twist. For 5, it remains as 1, 2, 3, 4, and we close with 5. And then for 6, it will be 1, 2, 3, 4, 5, and 6, and so on. So every time we get to a fifth one, we must close it. All right. So that is it for the numbers, working with numbers. And next, we deal with data handling. And in data handling, there are a few processes that we do, which is called the statistical process or a data cycle. So this is the second topic that we're dealing with, not in any order, by the way. So in this case, we have collecting data. So in data handling, we collect data to make decisions. So we can collect data about the number of learners, number of students each center has, the shoe sizes that each person can wear, the ages of people, the preferences of the type of cold drink. So some like Coke, others like Fanta, others like those kind. I'm now forgetting these cold drinks now. Some like Stone or what is called Stony. You have your lemon twist. Now it's called twist something, and then you have your twist granadilla as well. But in this case now we have we can collect data from a sample or from a population. A sample is simply a small group of items that represents the whole entire group, whilst the population is actually the entire group. So you can either collect data from your class, or you can collect data from the school. So your class can become a sample, and your entire school can become a population. All right. And then we have sources of data. We can get this data from peers, the community, newspaper, from books, magazine, or the internet. And we can collect data by means of making an interview, so asking people questions, just like when they do census counting us as the country. They will ask us questions, or you can fill out a questionnaire. You have a data collection sheet, all right, those kind of things. So there are many ways in which data can be collected. Next, we have to organize this data. So we organize it and summarize it. So we can organize it in a stem and leaf diagram. We can also organize it in a tally frequency table, and we can summarize the data using the statistics of the mean, the median, the mode, and the range. So I don't want to go deep into those. That's what you will also learn. And then displaying the data, we can represent data in a form of a bar graph or a double bar graph. We can also represent it in a pie chart as well as a line graph. So bar graph, it's something like when you have things like that. So that will be your bar graph, whilst your pie chart will be something like a circle where you would represent certain amounts like this. So then that is how your pie chart will look like. And then a line graph would be, maybe you can represent it as a line like that. Okay, now moving on, in terms of shapes and space. That's one of the topics that we can do, dealing with properties of shapes and solids. So solids are basically your objects, or a solid is a representation of an object, while shapes are actually the flat figures. So we have the basic two-dimensional shapes and three-dimensional objects or solids. So with figures we can have shapes, objects or solids, and with these solids we can also compare them whether they are prisms or pyramid. For instance, you can have a cylinder which is a prism, and a pyramid could be a cone, for instance. Or in this case, we can have a prism that is basically in a rectangular prism, or we can have a pyramid. So a pyramid will always have an apex, so a pointy shape at the top, whilst the base is any form of a shape. And then we have to draw shapes and nets of a three-dimensional shape and build models. So these are some of the shapes that we have to deal with. So we would have a square or a rectangle, triangle, different types of triangle. This is a pentagon, so we can have a pentagon which has 5 sides, and we can have a hexagon that has 6 sides, a septagon with 7 sides, an octagon which has 8 sides, and then we have a nonagon that has 9 sides, and a decagon that has 10 sides. And let me just stop there for now. Others, I'm not too sure about how they're called, but doesn't matter. And then we have a circle, all right, and this is called a rectangular prism. We can also have a triangular prism, and this is a cylinder. All right, so there are different shapes that we have to know. And then next we deal with calculations of space and shape. One of the calculations that we have to deal with is the calculation of a perimeter, which is the distance around the shape, and an area, which is the space inside a flat shape. So these are formulas of different shapes. For instance, this one is for a rectangular shape, and then this would be for a triangle, and this would be for a circle. Notice that these ones are P for perimeter, while this one is actually a circumference. Circumference is basically the perimeter of a circle. And then we also deal with volume in terms of calculations of shapes and space, volume, and we deal with surface area, where volume is the space inside the container, and the volume also, in fact, volume is the space that is occupied by a three-dimensional object, and it can also usually be interchanged with capacity, which is simply means the space inside the container, while the surface area is the total area of all the faces of a three-dimensional object. And we have to also deal with the theorem of Pythagoras, which says that in any right angle triangle, the square of the hypotenuse side is equals to the sum of the squares of the other two sides. So this can enable us to find any of the missing sides in this case. So if we were to write it in symbols, we would say b squared, this is the side, is equals to c squared plus a squared. So that will give us the value that we are looking for. And then we have to do a little bit of trigonometry. I know some people are very allergic to this one, but we have to do it, a little bit of trigonometry. So in this case, we have an angle here, which is angle C. And so it means for us, we could be standing here, all right? And when we are looking for any of the side, we can use any of these trig ratios here. So for instance, we can say cos of angle C will be adjacent. Adjacent simply means next to, so it will be adjacent divided by the hypotenuse, which will be this side here. All right, so that is why it is BC over AC. And then sine of angle C will be opposite over the hypotenuse. And then tan of angle C will be opposite over adjacent. All right, so that is basically how we identify the trig ratios. So that's basically it for this one here of measurements. And then we can also do, going back to numbers, we can also do solving of problems in context, and this will include dealing with percentages, percentage increase, and other ways in which percentage can be used, such as in simple interest and in hire purchase. So these are basically some of the formulas that are involved. We can also deal with budgets and loans and accounts. So that's solving problems in context or problems in everyday life. And then going into measurement again, we have to deal with the relationships with quantities. We have to check the relationship between mass and weight. No, so sometimes we normally deal with them as if it's same thing. So nobody asks you how much is your mass, but they will also ask you how much you weigh. So as if these are the same thing, but they are not actually the same thing. So if we were to talk about mass, mass would be we would talk about how much you weigh. You would say it is 90 kilograms. All right, but in weight you would say I weigh 9 newtons. So there is a difference between mass and weight, but in our everyday life, we normally talk about weight when we actually want to talk about mass or mass. All right, and then we have distance and displacement. So we have to check the difference between these two as well. So they are not the same, but we normally refer to them as the same. So we would say that distance is a scalar quantity and displacement is a vector quantity, but don't have to worry much about that for now. And then we have to deal with speed and velocity, and sometimes we would confine ourselves into kilometers per hour and meters per second, and sometimes it's represented this way. Speed and distance, the relationship between speed and distance, and obviously that will also involve time as well. All right, then we have to look into the instruments that are used, instruments and units that are used in dealing with the quantities that we're talking about. For instance, we can look into length and distance, and the units would be kilometers, meters, centimeters, and millimeters, and what can be used to measure the distance. You can use a trundle wheel, you know that wheel whereby people walk with a wheel. Usually it's police that have this kind of a wheel to measure, maybe for instance, how far did the car travel from when it maybe burst a tire up to when it had stopped. Or to measure the length of a soccer field, we use a trundle wheel. We can use a ruler, for instance, as well. We use a tape measure. Okay, people who sew and who put together clothes, they use a tape measure and stuff like that. Let me not dwell much on that. And we also have mass and weight. So I've just said that we can use newtons for weight. And then for mass, we have tons, kilograms, grams, and milligrams. There are many others, but we'll confine ourselves to these ones. Measurement of time. Obviously, we use a watch, clock, stopwatch to measure time and time that has elapsed. We use hours, minutes, and seconds, and sometimes we'll have to convert between these. We know 1 hour has 60 minutes, whilst 1 minute has 60 seconds, and that's what we need to do. With temperature, we don't do much except that we'll have to know that in South Africa we use degrees Celsius, and that is primarily where we will get to work with temperatures. In a very rare occasion, we would have to transition between degrees Celsius and degrees Fahrenheit, which are used. Fahrenheit are used in overseas countries, such as in America. So when, for instance, we would be talking about our temperature, maybe when you're scanning your temperature, they would say you have a temperature of 37 degrees Celsius. And then probably in America, I don't know what at the top of my head that would translate to. So probably they would say you have 89 degrees Fahrenheit in terms of temperature. So if they say your temperature is too high and they're talking about 89, so just ask them, is it in Fahrenheit or in degrees? All right. And then capacity, I've just explained what volume and capacity is, but normally we'd have to convert from a a solid state in terms of the volume, in terms of cubic centimeters, and we know that it will be equals to 1 milliliters. And then we have to deal with angles as well, your 0 degree and 90 degree and anything else in between. You have your 180 degrees as well, and you must know what these are also called. 270 degrees as well as 360 degrees, then you know that you're back at square one. So we deal with angles, and then the following one we have shapes, properties of shapes and space. Again, in this case we're dealing with transformations. So in transformations, our curriculum or the syllabus confines us to deal only with the transformation of translation, where we have to move something but we are not changing its direction. So we have to move it back, forth, front, and so on. And then we have rotation and reflection. I think I need to stop explaining now. Then we have to do some bit of congruency and similarity. In this case, we just have to identify whether something is congruent or something is similar. All right. So congruency simply means that two things are identical in every single way, whilst similarity simply means that the shape might be the same but the sizes might not be the same. And then in terms of space again, shapes and space, we deal with views of an object, and this generally they work together. From transformation you can go into views. All right, so we deal with views, how you view an object from different perspectives. So if you are viewing it from the top, this is what you will see. And if you are viewing it from a side, for instance this side here, this is what you will see. And if you're viewing it from the front, and this is what you will see. So this, if you're viewing it from this side here, this is what you will see here. So that is basically what happens in terms of views. Now let's move on to map interpretation. All right, our curriculum states that we have to deal with maps in terms of scales, but there could be other things that can be added in terms of maps. We can also deal with directions, where we look at your north, south, east, and west. Somebody says this is news. Okay, all right. And we can also look at the position. Um, where is something in relation to another location? So, and we have to deal with the grid reference, where we would say something is in block D4. So it would be in this block here. So we'd say it's D4. So sometimes students make an error of saying it's 4D, but actually it must be in alphanumeric. All right. In terms of scale, which is the big part of maps, we can have a numerical scale or a ratio scale where we say 1 is to 2500. So which simply means that 1 unit on the map will represent 2500 units on the ground or in reality. For instance, if we measure a distance, or we measure a length of something on the map, and we see that this is 1 centimeter, it simply means that it will represent 2500 centimeters in reality. Okay, so that's what it means. And then we can have a scale, a bar scale, like this. Now a bar scale or a line scale, which is simply a small iteration of this. So you would see that the distance from here to there is 5 kilometers, based on this one here that tells us that it is a kilometer. So if you would measure, if you have a distance, and when you bring it here, a distance on the map, and you bring it here and you find that it actually covers up to there, so you would know that this would be 15 kilometers. So for instance, if you then have a distance that starts from here up to maybe somewhere here, okay, so you can see that actually it is from 0 to 5, 10, 15 kilometers, but then this one is in the middle. So the middle between 15 and 20 kilometers, that would give us 17.5 kilometers. So that is basically how you would use your bar scale. And then the next topic that we might do is probability, which is commonly called chance. So this is the chance of something happening. So we have the probability of something happening. Now, not that it is a common thing, but a fairly used example is when we have a die, or sometimes we call it a dice. So it's one die and many dice. So we deal with the list of possible outcomes. So a die will have 6 sides, and so these are 6 possible outcomes. Calculating the probability. For instance, what is the probability that when you throw a dice you'll get a 3? So the die has the probability of 3. A die has one side that has a 3 out of 6 sides. All right, and then we also deal with two-way tables and a tree diagram, which your teachers can be able to explain those. And then finally on this page we have to deal with critically analyzing data. We analyze data from tables. So when we get a graph, we have to read the graph or the table and understand what it means and how it helps us to make decisions. We have to draw conclusion or make decisions based on the data that we have received, and then we must question the sources of data, because some data have errors and it might also have data that is manipulated to give us a certain picture, and which is not necessarily true. And then we might have to choose a suitable statistic. So is it better to use the mean, the median, or the mode? All right, so if for instance you are dealing with shoe sizes for women, for instance, you might be dealing with shoe sizes from size 3 up to size 8, for instance. But then if we then have a lady which wears size 13, so you can see that the mean then will not be the good um, statistic to use. It is best to use the median, because the mean will be affected by this bigger size. So on average we would say ladies wear between 5 and 6, because we are dealing with numbers from size 3 up to size 8. So the middle of that would be between 5 and 6. But if you would have somebody that wears size 13, then the mean might need to shift from 6 to 7, for instance, or to 8. Then you can't say the average shoe sizes for ladies is size 8. That would be incorrect. So the median would be a best place to be used, or we can even choose to look into the mode. So those are some of the things that we have to look in and basically study in order for us to be able to choose the best statistic between the mean, the median, and the mode. Next we have to do predictions. Predictions are made on issues. So we have to say, okay, if we have now made a decision that we are going to sell shoe sizes, we have to predict the future. Should we buy more of size 5 or 6 for women, or we can buy a lot of size 8? So you have to decide, but that decision would be based on what makes sense. So for instance, does not make sense to buy a lot of size 8 for women to sell, because there won't be many of those. So we know that the concentration of the shoe sizes for women would be probably between 5 and 6. I'm not a woman, so I'm not sure, but I'm just making an example, and sometimes an example. is not a truth. And so that is basically it. We have tried to cover the syllabus for mathematical literacy. So stay tuned and look out for our next videos, and keep working hard.